an amateur astronomer noticed something unusual in solar observation data, a faint smudge moving through space. That smudge turned out to be a brand new comet heading our way that we're now calling Comet R2 Swan.
NASA's announcement about the object designated R2 Swan streaking toward Earth has immediately set the scientific community and the public abuzz. To most, the name sounds almost like something from a science fiction script, but behind it lies a very real astronomical event that highlights both the immense scale of the cosmos and the fragility of our place within it. The tracking systems that constantly scan the skies for new celestial bodies first picked up R2 Swan as a faint point of light moving against the backdrop of stars, and further analysis quickly confirmed that it was headed in Earth's direction at remarkable speed. The precision of NASA's instruments leaves little doubt about its trajectory, and the speed at which this discovery was shared underscores its significance. Before we start, smash the like and subscribe buttons for more updates. The very name R2 Swan conjures images of grace and serenity, yet this object's approach carries a weight of urgency. As scientists mapped its orbit, the realization dawned that this was no distant wanderer simply passing harmlessly through the solar system. The velocity estimates placed it on a path of close proximity with Earth, fast enough to make the astronomical community sit upright. When objects travel through the solar system at such high velocities, every detail of their trajectory matters. The difference of a fraction of a degree in orbital inclination, or a slight variance in speed, could mark the difference between a breathtaking sky event and a direct encounter with the planet. What makes the situation even more compelling is that R2 Swan is not an object that had been on astronomers' radar for decades. Many comets and asteroids are cataloged years or centuries in advance, their returns and orbital swings carefully predicted long before they are visible again. R2 Swan, however, appeared suddenly, almost dramatically, a newcomer revealed only recently by the sweep of advanced telescopes. This abruptness is part of what adds intensity to the moment. The cosmos constantly produces new visitors, and Earth's relative smallness in the solar system means some are bound to come very near indeed. As the announcement spread, imaginations immediately turned to the implications of such a high-speed approach. An object barreling toward Earth forces consideration of scale. How large is it? What material composes it? Is it rocky, metallic, or icy like a comet? Each of these qualities would dramatically affect what happens if it penetrates Earth's atmosphere or comes into closer contact with our world. Scientists emphasize that even without immediate aftermath predictions, the sheer dynamics of the situation demand careful monitoring. Objects of substantial size moving at cosmic speeds can unleash energies dwarfing the most powerful weapons humanity has ever built. Yet this is not a story of panic, but of fascination. Humanity has always looked to the sky for meaning, inspiration, and guidance. Each time a new comet flares or a bright asteroid sweeps by, civilizations take note. Ancient cultures carve these moments into myth and legend, seeing in them omens or divine signals. Today, with instruments that can chart orbital mechanics down to fractions of kilometers and milliseconds, humanity views these events through the lens of science. But the awe remains the same. R2 Swan's trajectory is being charted not just for risk assessment, but for knowledge, offering a chance to study another piece of the solar system's puzzle. The speed at which R2 Swan is traveling is one of its defining features. Velocity in space is not just a matter of motion, it is a statement of force and potential. To visualize it, one might imagine a speck of dust striking a windshield while driving down a highway. At modest speeds, the speck leaves no mark. At hundreds of kilometers per hour, it could fracture glass. Scale that up to an object kilometers wide hurtling through space at tens of thousands of kilometers per hour, and the analogy becomes both sobering and staggering. R2 Swan is moving on cosmic terms, which means its energy, should it intersect with Earth, exists on a scale far beyond ordinary comprehension. The role of NASA in this announcement also highlights the global systems humanity has constructed to safeguard against cosmic surprises. Across the world, observatories, satellites, and automated surveys watch the night sky, recording countless points of light and tracking their motions with relentless precision. Every new detection adds to a database that allows predictions of where objects will be not only tomorrow, but decades and centuries from now. R2 Swan's sudden appearance demonstrates both the limits and strengths of this network. While not every object can be seen years ahead of time, the fact that this one was spotted in time to warn the world is proof of extraordinary vigilance. The public reaction is another layer to this unfolding story. As soon as news outlets began repeating NASA's announcement, curiosity took hold. People wanted to know whether it would be visible in the night sky, whether telescopes or even the naked eye could catch a glimpse. There is a dual fascination in watching something so vast and so near. One part fear, one part wonder. If conditions align, R2 Swan may blaze bright enough to etch its presence across the firmament, a reminder of our planet's exposure to the broader workings of the solar system. In scientific terms, every visitor from deep space carries within it clues to the formation of planets, the chemistry of early solar systems, and the dynamic forces that continue to shape them. If R2 Swan is indeed a cometary body, its icy components may preserve ancient material unchanged since the birth of the Sun. Such an object hurtling toward Earth is more than a potential hazard. It is a messenger from the dawn of time, carrying secrets waiting to be unraveled by instruments capable of parsing its chemical fingerprints. Yet velocity complicates study. The faster an object moves, the harder it is to capture high-resolution data before it slips past. Instruments must track, lock on, and analyze in fractions of time that challenge even modern technology. Astronomers already race to coordinate global observatories, ensuring that from every corner of the Earth, telescopes can turn toward R2 Swan and gather as much information as possible during its approach. Time is compressed, urgency heightened, and with every passing hour, the object grows brighter and clearer in the instrument's gaze. For humanity, the very act of witnessing such an approach is a reminder of cosmic vulnerability. Earth orbits serenely, shielded by its atmosphere and magnetosphere, but not invincible. The annals of geology tell the story of past collisions, craters scattered across continents, scars of impacts that forever altered the planet's course. While no predictions of aftermath are made in this moment, the simple acknowledgement that something large and fast is heading near Earth resonates deeply. It is not just a matter of science, but of perspective, reminding us that we inhabit a planet within a dynamic and sometimes unpredictable solar system. As R2 Swan continues its journey, more details emerge. Its brightness fluctuates, suggesting jets of material escaping as sunlight strikes its surface. These eruptions are like cosmic geysers, hurling vapor and dust into space, giving the object a hazy envelope that may evolve into a magnificent tail. To the human eye, such a display transforms a pinpoint of light into a sweeping arc across the stars, the kind of spectacle that has inspired poets, chroniclers, and skywatchers since the beginning of recorded history. Even the naming of R2 Swan carries weight. Such designations follow a systematic process, but they also lend character to what might otherwise be anonymous rocks and ice. By giving it a name, humanity personalizes it, turning an anonymous cosmic traveler into a protagonist in the unfolding drama of the skies. That name now echoes across headlines, in classrooms, and in conversations, anchoring a moment in history when something beyond Earth demanded attention. As the scientific community continues its watch, the layers of implication stretch outward. The event underscores why planetary defense has become a serious field of research. Tracking systems, early warning networks, and technologies designed to alter trajectories are no longer speculative fiction but active pursuits. Each near-Earth object, each new detection, adds urgency to these preparations. R2 Swan's rapid approach illustrates how quickly an untracked body can appear, and how critical it is to refine the tools that stand between Earth and potential cosmic calamity. Beyond science and defense, there is also the human element of imagination. Artists sketch visions of what R2 Swan might look like if glimpsed against the horizon. Filmmakers imagine stories woven around its arrival. Children, hearing the name, look skyward with a blend of curiosity and unease. Events like this ripple through culture as much as through science, becoming shared touchpoints for entire generations. Decades from now, people may recall where they were when NASA announced R2 Swan's approach, just as earlier generations recall comets or eclipses that define their own times. The rapid spread of information in the digital age ensures that R2 Swan is not just an astronomical event, but a global conversation. From social media posts to late-night discussions, from radio hosts to classrooms, the approach of this object has become a unifying topic. In every corner of the world, people connect over the wonder of the skies. This shared experience reveals something profound, that despite divisions of geography or culture, humanity collectively gazes outward in moments like these, drawn together by the vastness beyond. The tracking data also highlights the interconnectedness of international science. While NASA delivered the official announcement, countless observatories around the globe contributed to detecting, verifying, and modeling the path of R2 Swan. This cooperation exemplifies the best of human endeavor. Nations and institutions transcending boundaries to piece together a picture of the cosmos. The object's arrival becomes not just a challenge, but an opportunity for collaboration, advancing knowledge in a way that belongs to all. As days pass and R2 Swan grows closer, its image sharpens. Photographs spread across news feeds, telescopic captures revealing fine details of its surface and halo. Each new frame becomes a study in contrasts. The cold, inert stone and ice of space meeting the fiery energy of solar radiation. The interplay creates a spectacle both alien and familiar, for while it originates far beyond Earth, its presence now dominates human attention here at home. In essence, the announcement that R2 Swan is heading toward Earth fast is more than a scientific bulletin. It is a narrative of encounter, of humanity meeting the cosmos in a moment of heightened awareness. It is a reminder of the fragile, spinning sphere we inhabit, set within a system that remains alive with movement and surprise. It compels awe, study, preparation, and imagination all at once. The implications stretch from laboratories to living rooms, from telescopes to human hearts. The story of R2 Swan will continue to unfold as its approach is tracked moment by moment. For now, the knowledge of its path alone is enough to reshape perspectives. Every glance upward, every chart produced, every whispered conversation about the object deepens the realization that Earth does not exist in isolation. It is part of a vast dynamic dance, in which sudden visitors like R2 Swan sweep in to remind humanity of its place in the cosmos. The discovery and announcement of R2 Swan's rapid approach set into motion a cascade of scientific focus, cultural attention, and philosophical reflection. With each passing day, its presence in the night sky becomes more pronounced, its story unfolding layer by layer as humanity directs telescopes, cameras, and imaginations toward this unexpected visitor. The narrative of R2 Swan continues to deepen, not through repetition of known facts, but through the widening scope of what its journey means for science, society, and the very way we see ourselves in relation to the cosmos. At the heart of this unfolding chapter is the extraordinary pace of the object. Speed in the context of space is always relative, yet when astronomers describe R2 Swan as fast, the magnitude is breathtaking. It is velocity measured not in hundreds, but in tens of thousands of kilometers per hour, a rush of motion that defies everyday comprehension. For scientists, this rapid approach poses both opportunities and obstacles. Instruments must react with precision timing, carefully calibrated to track something that is here one moment and shifted significantly across the sky the next. Observatories coordinate globally to ensure that when one hemisphere slips into daylight, another picks up the watch seamlessly. The choreography of Earth's scientific infrastructure becomes a ballet performed under pressure, with R2 Swan as the central dancer in a cosmic performance. The fascination with its speed also carries implications for public imagination. The idea of something approaching Earth so quickly has a visceral effect. People intuitively grasp the concept of momentum and impact from daily life, whether in vehicles, sports, or storms. Translate that instinct to the scale of a celestial body, and the awe intensifies. Artists and writers seize upon this theme, portraying R2 Swan as a harbinger of unstoppable force, a streak of brilliance tearing through the heavens with a kind of inevitability that feels almost mythic. Meanwhile, astrophysicists analyze the dynamics behind that speed. Was R2 Swan flung from the far reaches of the Oort cloud, drawn inward by the sun's gravity after eons of silent drifting? Did it perhaps pass near another massive body whose gravitational slingshot accelerated it into this dramatic trajectory? Every possibility offers clues about the unseen mechanics of the solar system's distant regions. Studying its orbital path not only informs predictions of its journey, but also provides insights into the hidden architecture of the cosmic neighborhood. places far beyond the reach of current spacecraft. The surface of R2 Swan itself becomes a subject of speculation and study. High-speed bodies carry histories etched into their crusts, craters from ancient collisions, fractures from past encounters with solar heat, and outgassing vents where volatile ices sublimate into space. As sunlight intensifies along its path, faint hazes form, suggesting chemical reactions and eruptions of vapor. Astronomers detect spectral signatures that hint at its composition, each reading a tiny fragment of a larger story. Ammonia, methane, carbon dioxide, or more complex organics could be present, and each would reveal something vital about the building blocks of the early solar system. The act of deciphering these traces becomes a scientific treasure hunt, carried out in the narrow window of time before R2 Swan recedes back into the deep. For the broader public, the visual spectacle begins to emerge. Reports filter in from stargazers who spot a faint smudge in the pre-dawn sky, then describe its nightly growth into a more defined streak. Photographers capture long exposures, revealing tales of light that the naked eye cannot fully perceive. Communities organize viewing nights, gathering in parks and open fields, telescopes pointed upward, eyes searching for the fast-moving beacon. In urban environments where light pollution often obscures the stars, R2 Swan cuts through, a visible reminder of the grandeur that lies beyond street lamps and skyscrapers. The symbolic weight of such a phenomenon grows steadily. R2 Swan becomes not just an astronomical curiosity, but a canvas upon which societies project meaning. Spiritual leaders speak of it as a sign of unity, a shared moment where all people can look skyward and see the same thing, regardless of nation or creed. Environmental thinkers use it as a metaphor for planetary stewardship, reminding humanity that Earth is a fragile oasis within a vast, indifferent expanse. Politicians and educators invoke it in speeches, drawing connections between the celestial visitor and the need for global cooperation, scientific investment, and curiosity-driven research. While cultural interpretation flourishes, the scientific community remains grounded in rigorous observation. International collaborations accelerate, with data streaming into central repositories accessible to researchers worldwide. Teams working on orbital mechanics refine models hour by hour, integrating new readings into simulations that map possible trajectories with ever greater accuracy. Space agencies share radar imaging, spectroscopic analyses, and thermal data, each layer adding depth to humanity's portrait of the approaching object. The level of cooperation highlights a truth: that cosmic events of this magnitude transcend borders, compelling collaboration that mirrors the object's impartial journey across the skies. The scientific urgency is further heightened by the unique challenges posed by R2 Swan's velocity. To capture detailed imagery, instruments must track with extraordinary precision, moving in sync with a point of light that shifts rapidly across the backdrop of stars. This requires not only advanced machinery, but also human ingenuity, with astronomers and engineers devising novel methods to stabilize telescopes, compensate for motion, and filter atmospheric distortion. It becomes a real-time test of technological prowess, demonstrating the cutting edge of observational astronomy. The educational impact is equally profound. Classrooms around the world seize on R2 Swan as a teaching moment, weaving its approach into lessons on physics, mathematics, and history. Students calculate orbital paths, debate the significance of speed and momentum, and trace parallels with past celestial visitors that left their mark on human history. Teachers emphasize the beauty of discovery, the thrill of being alive at a moment when the cosmos reveals something unexpected and spectacular. Children look skyward with questions, some of which may guide their futures into careers in science, engineering, or exploration. Artistic responses, too, deepen with time. Musicians compose pieces inspired by the swift and luminous passage, blending orchestral crescendos with ethereal tones to mimic the feeling of witnessing something vast and fleeting. Painters create sweeping canvases in which R2 Swan dominates the sky, its glowing tail mirrored in oceans or reflected in the eyes of awestruck figures. Writers craft stories that intertwine its path with human lives, exploring themes of destiny, inevitability, and wonder. In every medium, the celestial visitor becomes more than a rock or an icy body. It becomes a muse. Philosophers and thinkers extend the dialogue further still. R2 Swan's approach sparks debates about humanity's place in the universe. Some interpret it as a humbling reminder of our vulnerability, a symbol of forces beyond our control. Others see in it a celebration of knowledge, proof that through science and cooperation, humanity can perceive and understand phenomena that once would have gone unnoticed until they passed by unobserved. Discussions unfold in journals, lecture halls, and public forums, each perspective adding another layer to the collective response. Meanwhile, the object itself continues its relentless journey, indifferent to the meaning ascribed to it. Its surface glimmers faintly under sunlight, shedding particles that create a shimmering trail. In some regions, this trail becomes visible even without instruments, stretching across the horizon like a luminous scar of motion. To many, the sight evokes feelings both exhilarating and eerie, a reminder that Earth is part of a dynamic system where bodies can appear suddenly, dominate the skies briefly, and vanish again into darkness. The economic implications of R2 Swan's approach also find their way into discussions. Space-related industries highlight the event as evidence of the importance of monitoring technologies, defense strategies, and exploration missions. Investors see it as validation for funding asteroid mining concepts or planetary protection initiatives. The presence of R2 Swan becomes a tangible reference point for the otherwise abstract business of space economics, showing that celestial bodies are not distant ideas, but real, tangible entities with measurable impact on human thought and planning. Amid these layers of impact, the sensory experience remains paramount. To witness R2 Swan directly is to feel a connection that transcends analysis. Its light reaches Earth after traveling across the void, photons carrying the story of its motion across millions of kilometers, now striking human eyes with immediacy. Each glimpse is a reminder that the cosmos is not silent but alive with travelers, some fleeting, some recurring, each adding a chapter to the saga of the skies. Scientists press forward with measurements of its brightness curve, noting how it flares and dims unpredictably. Such fluctuations hint at internal processes, fractures opening, vents releasing gases, or tumbling motions that alter how sunlight reflects. Every irregularity enriches the narrative, turning R2 Swan from an abstract dot into a complex evolving body with a story of its own. The unpredictability becomes part of the fascination, a puzzle that draws observers back night after night. The connection to history also strengthens as scholars draw parallels with famous comets and objects of the past. Accounts of Halley's Comet, Comet Hale-Bopp, and the Tunguska event surface, reminding the world that humanity has always been shaped by celestial encounters. Ancient chroniclers spoke of fiery streaks in the sky as omens. Now scientists translate them into data, yet the sense of awe remains strikingly similar. R2 Swan joins this continuum, a new chapter in humanity's shared memory of the cosmos. Beyond professional science, citizen astronomers play a vital role. Enthusiasts with modest telescopes contribute data, photographs, and reports to central databases. Amateur observers record variations in brightness, track motion across constellations, and sometimes notice subtle shifts before professionals confirm them. This democratization of observation emphasizes that R2 Swan belongs not just to institutions, but to everyone under the sky. Each person with curiosity and equipment can participate in the unfolding discovery. The unfolding of R2 Swan's approach is therefore not just a singular event, but a tapestry woven from countless threads. The rigor of astrophysics, the creativity of art, the unity of culture, and the immediacy of human experience. Its speed, brightness, and trajectory combine to form a moment that is both scientific and symbolic, fleeting, yet enduring in memory. With each day, the world's gaze remains fixed upward, captivated by a visitor that reminds humanity of both its vulnerability and its brilliance. This chapter of R2 Swan is not one of closure, but of expansion. The more is learned, the more avenues open for exploration. Avenues of knowledge, imagination, and meaning. The skies are not empty, but alive. And in the fleeting arc of R2 Swan across Earth's heavens, humanity encounters a truth that resonates beyond numbers and models. That to look upward is to discover not only the cosmos, but ourselves. R2 Swan's swift emergence into global consciousness did more than ignite scientific inquiry and spark cultural fascination. It also revealed how intertwined human progress is with the wider cosmos. The moment of its announcement marked a pivot point where disciplines beyond astronomy found themselves caught up in the momentum of the story. Every sector, from technology to philosophy, from governance to art, began to frame its own perspective on this streak of matter moving through the void toward Earth. To expand on this moment without retracing what has already been said, it becomes vital to explore new frontiers of meaning and implication, avenues that stretch into politics, communication, spirituality, psychology, and the very future of human exploration. One striking consequence of NASA's announcement was the immediate response within the political arena. Leaders in multiple countries found themselves asked questions they had not anticipated just days before. News agencies demanded statements, and legislatures were suddenly peppered with debates on whether planetary defense funding was sufficient. Even if R2 Swan were destined to pass by at a safe distance, the psychological effect of hearing that an object was heading towards Earth fast carried weight that no politician could ignore. Some leaders seized on the moment as proof of the necessity for international cooperation, while others treated it as an opportunity to advocate for investment in national space programs. The result was a rare convergence. Regardless of ideology, every faction recognized that the cosmos is indifferent to borders, and that preparation is a matter of shared survival. This moment also underscored how information travels in the digital age. Decades ago, an announcement like this might have filtered slowly through newspapers or radio broadcasts. Today it surged instantly across social platforms, accompanied by hashtags, live streams, and endless commentary. The velocity of information mirrored the velocity of R2 Swan itself, fast, direct, and unavoidable. Within minutes, millions knew of its approach, and within hours, interpretations proliferated across languages and cultures. Memes, simulations, and speculative illustrations filled feeds, blending humor with genuine concern. The global network amplified the sense that humanity was witnessing a collective moment in real time, regardless of location. The psychological aspect of such an announcement is profound. Human minds are not wired to fully comprehend astronomical scales, yet they instinctively respond to the idea of something large and fast approaching. Anxiety mixes with fascination, producing a unique emotional cocktail. For some, R2 Swan became a source of dread, stirring primal fears of forces beyond control. For others, it represented pure wonder, a chance to be alive at a moment of cosmic drama. Psychologists noted how discussions about the object quickly expanded into conversations about mortality, resilience, and the meaning of existence. It became not just a scientific story, but a mirror reflecting humanity's deepest insecurities and highest aspirations. Religious communities, too, responded with their own interpretations. In temples, mosques, churches, and synagogues, the appearance of a sudden celestial body racing toward Earth sparked sermons and meditations. Some saw it as a reminder of divine majesty, a sign that the heavens remain active and mysterious. Others emphasized humility, pointing out that no matter how advanced technology becomes, humanity remains at the mercy of forces larger than itself. Still others wove it into eschatological frameworks, treating it as a possible precursor to fulfillment of long-standing prophecies. While science provided data, faith communities provided meaning, weaving R2 Swan into centuries of cosmological storytelling. Educational institutions seized on the moment in ways that went beyond classroom lectures. Universities hosted emergency panels where astrophysicists, ethicists, and political scientists debated the implications. Planetariums extended their hours, projecting simulations of R2 Swan's trajectory onto domes for awestruck audiences. Libraries curated displays of historical comet sightings, placing this modern event within a lineage that stretches back to Babylonian tablets and Mayan codices. For many young people, the event represented their first visceral encounter with the vastness of the universe, a spark that could ignite lifelong curiosity. Even as formal institutions adapted, grassroots communities organized their own responses. Amateur astronomy clubs scheduled night watches, live streaming their observations for a global audience. Artist collectives painted murals inspired by the object, using its approach as a metaphor for speed, change, and uncertainty. Musicians staged impromptu concerts beneath the stars, blending sound with the silent motion of the cosmos. These acts of communal creativity emphasized that R2 Swan was not only a matter for scientists and governments, but also a shared canvas for human expression. The economic world found itself adjusting in subtler ways. Insurance companies, while not predicting direct consequences, quietly analyzed how they might respond if near-Earth objects became more common in public discourse. Would anxiety about celestial events influence investment in certain industries? Could tourism spike as people flock to observatories or remote regions for a clearer view? Entrepreneurs in the space sector saw the announcement as a marketing opportunity, emphasizing the importance of innovation in asteroid detection, resource extraction, and spaceflight technology. In boardrooms, R2 Swan was not merely a rock in the sky, it was a conversation starter about the value of resilience in uncertain times. Philosophers and ethicists introduced another layer of dialogue. If humanity were one day to possess technology capable of deflecting or destroying incoming bodies, what ethical framework should guide its use? Who decides which actions to take, and how to balance the risk of doing nothing against the potential unintended consequences of intervention? Though R2 Swan itself did not demand immediate defensive measures, its rapid approach highlighted these unresolved questions. Theoretical discussions about the ethics of planetary protection suddenly felt urgent and tangible. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA announcing R2 Swan's fast approach toward Earth? We want to hear from you. Thank you for watching and see you next time.